Assalamualaikum and hi everyone. So, without further ado, let's get into the introduction. So, a solid foundation is the key to every building project success. For the purpose of creating a sustainable foundation building, an analysis of the precise properties and engineering requirements at the intended location is crucial. So, in this individual mini project, students are required to conduct certain soil engineering tests that can be associated with soil mechanics fundamental concepts and describe the soil in terms of the particle density, liquid limit of soils, and plastic limit of soil. Also, soil can be classified according to its moisture content as solid, semi-solid, plastic, and liquid. Every state has a unique consistency and behavior, which results in unique engineering qualities. By using Atterberg limit test to identify changes in the behavior of the soil, it is possible to define the boundary between each condition. What is the aim and objective of this mini project? So as stated, the aims and objective for this task is to get particle density, liquid limit, and plastic limit of soil through soil testing. For the particle density test, we need to conduct a test to figure out the moisture content and particle density test by determining specific gravity of soil through density water test. Next, to determine the plastic limit and liquid limit of a soil, we need to conduct the Atterberg limit test, which is Casagrande we use for the liquid limit test, and cone penetration for plastic limit test. So let's get to the next step, which is the process. First step is the particle density test. From this test, we use the vacuum sets or the desiccator. We use 400 grams of soil and 5% of rice husk. From this experiment, we managed to get the specific gravity, which is 2.39. Next, cone penetration and Casagrande test. From this both experiment, we managed to calculate the water content, which is 32.04%. For the discussion, in the particle density, utilizing the solid specific gravities, one may determine the density of soil solids. The basic gravity of the substance is multiplied by the density of water to get this. Engineers can determine a soil specific gravity to determine how porous and how many void it has. Additionally, it helps engineers determine if the soil is suitable for building. Next, for water content, to ascertain the water content, this experiment was carried out. This test This test significance lies in its ability to categorize the soils in various states. The use of empirical correlation for engineering attributes is also permitted by the Atterberg limit test. By calculating the average water content, the plastic limit was established. For overall discussion, in order to measure the amount of water contained in the soil for the water content experiment utilizing the plastic limit, we must find the masses of solid soils and water. Additionally, we must use the following formula to determine the revised specific gravity, which is Gs equal to K multiplied by Gs. For the purpose of the particle density test, K is the relative density of water at room temperature divided by the relative density of water at 27 degrees Celsius. Next, the conclusion for water content, we can infer from the result of the experiment that the goal of this study has been accomplished. The soil sample's water content was calculated. Students were taught the usefulness of the Atterberg limit test through these experiments, which determines the liquid and plastic limits in order to define soil behavior. In addition to the Atterberg limit test, the sand bath method can be used to determine the water content besides the desiccator method. In particle density, this test was carried out satisfactorily. The density that can be attained for any soil with a specific quantity of compaction work relies on the moisture levels. The soil must be compacted to nearly saturation, where virtually all the air is forced out in order to get the maximum dry density at very high moisture levels. The soil particles interact with one another at low moisture contents, therefore adding more moisture will allow for higher bulk density, with the peak density where these impacts start to be offset by the soil saturation. For the experiment to be successful, the weather won't be dry enough to collect the required data. The classification of particle size and texturing also follow. It is essential to utilize a mechanical shaker to properly filter the dirt. The fluid density test additional goal is to figure out a soil's dry density. We must perform the experiment at a minimum of 3 times to obtain an accurate measurement of the soil density. Last but not least, permeability showed how quickly water can move through soil particles. Use the porous stone to securely hold soil samples at both ends while allowing water to pass through it freely. So that's all for me. Thank you.